Hello, in this video we will talk about fragmentation. Fragmentation is an important concept in memory management. The definition and idea are simple. Fragmentation is a phenomenon caused by inefficient, wasteful use of memory. Now, in college-level programs, you usually use the default and implicit memory management provided to you by programming languages and operating systems. Thus, you don't have to think about how exactly memory is allocated to your program. But the operating system's course is meant to give an in-depth look at what's going on under the hood, and fragmentation affects operating systems, programming languages, and the way you create programs in the, so to say, real world. Memory can be used inefficiently in two ways. We can allocate a process more memory than it needs. In this case, the extra memory remains unused. This situation happens when memory allocation is done in chunks of a fixed size. Think about paging with 4 kilobyte pages. You can give a process 4 kilobytes, one page, or 8 kilobytes, two pages, but you cannot give a process exactly 6 kilobytes. If a process asks for 6 kilobytes of memory, it receives 8 kilobytes. The extra 2 kilobytes won't be used, but will be reserved for the process. Those 2 kilobytes are effectively wasted. This is an example of internal fragmentation, when memory is wasted because the process receives more than it needs. We can have another scenario where memory isn't given to any process but is still unusable. At first it might sound strange. If memory is unused, why can't we use it? This situation happens because when we need memory, we need chunks of it of a certain size. If the memory has empty chunks that are small in size, then those chunks may be less than what is usually needed. Therefore, those chunks are useless. Such fragmentation is called external fragmentation. We call chunks of free memory holes. Let's see how small holes can appear in the memory. Think about a system that uses contiguous memory management. Contiguous memory management means that the process is placed in the memory as a single contiguous chunk. Here is a picture of the memory that can be used for processes. Right now it has nothing in it. First arrives process A. It needs that much memory. Then arrives process B. Then process A terminates. A hole appears in the place where process A was. Then arrives process C. Process C is a little bit smaller than process A. If process C is placed where process A was located, there will be a small hole remaining. As the system functions, processes come and go, and such small holes can eat up a significant portion of the memory. We just discussed external fragmentation using the example of a system with contiguous memory allocation. This example is a classic textbook way of understanding external fragmentation. However, we must mention that the same external fragmentation problem arises in, for example, dynamic memory allocation on heap. Let's sum it up. Fragmentation is the phenomenon of inefficient, wasteful use of memory. There are two types of fragmentation: internal and external. Internal fragmentation happens when we give a process more memory than it needs. It happens in systems that allocate memory in chunks of a fixed size, such as systems that use paging memory management. External fragmentation happens when we have memory holes so small that no process can use them. It happens in systems that allocate memory in chunks of variable size, for example, systems that use contiguous or segmentation memory management.